Hello, in this video I'm going to work on another example of how to find where a line intersects with a curve. In other words, I'm going to discuss and work on another example on how to solve simultaneous equations, where one equation is linear and the other is quadratic. And I'm going to be using the substitution method. And the problem I have in front of me actually looks like a lot of fun, if not a bit involved. And so we are given that 2x plus 3y equals 7, or no, sorry, equals 13. 2x plus 3y equals 13, and x squared plus y squared equals 78. So there's our line, here's our quadratic, it's actually a circle, but equation 1 and equation 2. And we have two unknown variables, and so we need to solve this simultaneously. And the best way to go about this, I think, is that this first equation can simplify nicely. We can isolate this x value. We can isolate x, I should say, by dividing by 2 right across this entire equation, which will give us x plus 3 over 2y equals 13 over 2. And now we can subtract 3 over 2y from both sides. So x equals 13 over 2 minus 3 over 2y. And I'm just going to box that off because we need to remember this. And so now I'm just going to substitute. We know x equals 13 over 2 minus 3 over 2y. I'm going to substitute this into equation 2. Okay, which is x squared plus y squared equals 78. And so x is squared. So it's going to be 13 over 2 minus 3 over 2y squared plus y squared equals 78. And actually, just as I was writing that out, I realized that we could still simplify this by factoring out 1/2. And so it would look something like this. It would be just 13 minus 3y. And this would be a little bit easier to manage because we could just multiply by 2 right across. It would cancel out and on, and it'd be much more simple, I think, in the working. But I'm going to keep it this way, just for fun, I suppose, just to offer a bit more of a challenge. And so what we're going to need to do, what I will do now, is FOIL this out. It's 13 over 2 minus 3 over 2y. I'm going to FOIL it out. So we've got 13 over 2 minus 3 over 2y times 13 over 2 minus 3 over 2y. And of course we have still have this plus y squared term, and then all of it is set to equal 78. So yeah, we're going to FOIL all of this out now. So 13 over 2 times 13 over 2. Well, 13 times 13, I think, is 160. Let's look. 13 times 13. 3 times 3 is 9. 1 times 3 is 3. We've got our 0. 3 times 1 is 3. 1 times 1. It's going to be 169. So this is going to be 13 over 2 times 13 over 2 is 169 over 4. And now we have 13 over 2 times negative 3 over 2. Well, 13 times 2 is 26. And you add another 13, that's going to be 39. And so we'll have, and it's negative, so negative 39 over 4y. Negative 39 over 4y, yeah, and now we have negative 3 over 2y times 13 over 2, which is, we already found that out, is going to be negative 39 over 4. Sorry, I was just rethinking the first term here. So yeah, so now we got negative 39 over 4y, and now we've got negative 3 over 2y times negative 3 over 2y. One double negative is going to be positive. 3 times 3 is 9, so it's 9 over 4 y squared plus y squared equals 78. Right, now we can collect our like terms and just simplify all of this. And so we've got two y terms here, 39 over 4 y minus 39 over 4, negative 39 over 4y minus 39 over 4. That's just going to be minus 39 over 2. So this is all just going to be negative 39 over 2y. And we have 9 over 4 y squared plus y squared. So 9 over 4 plus 1, that's going to be 9 plus 4, so it's 13 over 4 y squared. So 13 over 4, we can rewrite all of this as 13 over 4 y squared minus 39 over 2y plus 169 over 4 equals, and all that's going to still equal 78. So it's definitely more involved and more complicated this way. It would have been so much easier, I think, if I factored out 1/2 up here, and I would have just been left with 13 minus 3y. But whatever, this will be would be a nice challenge, I suppose. A good revision in the very least. So the next thing I want to do is multiply this entire thing by 4, I think, because that will cancel out the denominator here. It'll cancel out the denominator here. 39 times 4, I'm just thinking ahead for a moment. Well, 9 times 4 is 36, and 3 times 4 is 12, plus 3, that's 156. 156 is certainly divisible by 2, and I'm just trying to think, because 75 plus 75 is 150, so that would be 78. Yeah, okay, so yeah, sorry, I'm thinking aloud. So I'm going to multiply this entire thing by 4. This should work out nicely, I think. So that's going to cancel out the denominator here. It's going to cancel out the denominator here. So we're left with 13y squared minus, we know that 39 times 4 is 156. So it's 156 over 2y, and then the denominator cancels out here, so it's 169. And 78 over 4, I don't know that on the top of my head. 8 times 4, is 32. We've got our 3. 7 times 4 is 28. Plus 3 is 31, so it's 312. Oops, 312. So this equals 312. So it's starting to simplify a little bit. And we know, as I mentioned earlier, 156 is divisible by 2. It's 78. So I can rewrite all of this again as 13y squared minus 78y plus 169. All of that equals 312. Now, the instinct, or my inclination, is to divide this entire thing by 13. The question is everything here divisible by 13? Because that would simplify it very, very nicely. 78, I know for sure, is divisible by 13, because I'm pretty sure 13 times 6 is 78. Yeah, so 3 times 6 is 18, we got 1 times 6, yeah, 78. So that's divisible by 13. 169 is certainly divisible by 13, because it's a perfect square. 13 times 13 is 169. So 169 divided by 13 is going to be 13. So that's perfect. And 312, I don't know. I'm going to have to do some division here. Don't know this off the top of my head. But 13 times 2 is 26. Oops, sorry. I don't know why I wrote it that way. So that's 2. 2 times 13 is 26. 31 minus 26, that's 5. Bring down the 2, it's 52. 52 divided by 13 is 4. because 52 times 3, what am I doing? 13 times 3 is 39, and then we add 13, that's 52, 49 plus 3, yeah, 52. So it goes 13, so yeah, 52 divided by 3, that's, yeah, 4, and yeah, okay, so yeah, so we have no remainder because 4 times 13 is 52. Yeah, so it's going to equal 24. So this entire thing is in fact is divisible by 13. So we can rewrite this, just divide the entire thing by 13. So y squared minus 6y plus 13 equals 24. We found that this equals 24. Now the next step, we're getting really close, I think, is we need to subtract 24 from both sides. So that's going to be y squared, well, I should write that more neat to avoid confusion, y squared minus 6y, and 24 minus 13 is 11, but it's going to be negative, so negative 11. All of that sets equals 0. Right, so we need, the whole point of this, all of this mess is to find the values of y, right? So, but this isn't going to be very simple to factorize, actually, because AC is going to equal negative 11, and 1 and 11 is, and we need to add to negative 6. That's just nowhere near negative 6. So to factorize this is going to be a bit of a nuisance. But the question does state in surd form, which is a giveaway, because we can use the quadratic equation here. We will certainly end up with a surd, I think. So A is 1, B is negative 6, C is negative 11. So we've got, maybe I'll just write that. So that's A, B, that's C. We know the quadratic equation. It's minus B plus minus the roots. B squared minus 4AC, all of that over 2A. So, just scroll down, give myself some space. So negative, so B, well, it's going to be negative. B is minus 6, it's double negative. So what we'll end up with here is 6 plus minus the roots of B squared, which is negative 6 squared, minus 4 times A, which is 1, times C, which is negative 11. Don't want to make any errors. 2A, that's just 2. 2 times 1 is 2. Right, so we can simplify everything here. Let's work this out. So 6 squared is 36. Negative 4 times 1 is negative 4. Times negative 11 is 44, so it's going to be plus 44. 36 plus 44. Well, 36 plus 4 is 40, and you're left with 40, so it's going to be 80. So we have 6 plus minus, and all of this right here simplifies to 80. So we've got the square root of 80 over 2. Now we can simplify this, because if I draw a factor tree, sort of follow along with the logic, and think through this a bit. 80 is 8 times 10. 8 is 2 times 4. 4 is 2 times 2. So we can factor out a 2. We've got a 10 here, which is 2 times 5. And we can factor out 2 2's, so it's 4 root 5. So this, I'll just write it up here to save space. This root 80 is going to be 4, simplifies to 4 root 5. Now we're getting somewhere, because we can divide this 6 by 2. It's going to be 3, and this 4 by 2, it's 2. So all of this simplifies finally to 3 plus minus, 2 root 5. So y equals 3 plus 2 root 5, or 3 minus 2 root 5. We have two solutions, which is exactly what was to be anticipated. And so now we have made significant progress, but now we need to substitute those y values into this equation. X equals 13 over 2 minus 3 over 2y to get the corresponding x values, and we will be done. We will have found where the line intersects with the curve. So I'm going to rewrite that down here. X equals 13 over 2 minus 3 over 2y. And now, so when, I'll just write it this way, when y equals 3 plus 2 root 5, x equals, so now we're finding the corresponding x value, so it's going to be 13 over 2 minus 3 over 2, and now we know y equals all of this, so 3 over 2 times 3 plus 2 root 5. And we should be able to simplify this. Should be okay. So I'll just write it across. I need to start saving a bit more space. So we've got 13 over 2 minus, well, 3 over 2 times 3, that's 9 over 2. So we've got minus 9 over 2. And now 3 over 2, it's a negative 3 over 2, times 2 is negative 6 over 2 root 5. And we are almost done here. Getting very, very close now, because 13 minus 9 is 4. So this is right, this 13 over 2 minus 9 over 2 is going to simplify to 4 over 2, which in and of itself, that it also that simplifies to 2, because 4 divided by 2 is 2. So now we have 2 minus, and 6 over 2 is 3. So it's going to be 2 minus 3 root 5. 2 minus 3 root 5 is what x equals when y equals 3 plus 2 root 5. So I'll write it this way. So our first set of coordinates is going to be 2 minus 3 root 5 comma 3 plus 2 root 5. So that's one point of intersection. So we are getting very close here, and now we just need to find the remaining corresponding x value when y equals 3 minus 2 root 5. And this should be quite simple because we've already done the arithmetic. It's actually just going to be a little bit repetitive here, with one or two minor changes I anticipate. So when y equals 3 minus 2 root 5, x equals 13 over 2 minus 3 over 2, and y equals 3 minus 2 root 5. Right, so we just need to distribute, employ the distributive property here. Again, just as we did before, we know that's negative 3 over 2 times 3. So actually, so we've got 13 over 2 minus, that's going to be 9 minus 9 over 2. And this is going to be plus, we got a negative 3 over 2 times negative 2. So it's going to be plus 6 over 2 root 5. Did I do that right? 3 and 3, 9 over 2, yeah, okay. So this simplifies 13 over 2 minus 9 over 2, that's 4 over 2, which again simplifies to 2. So here we are, this is the end. So we're going to have 2 plus, and 6 divided by 2 is 3, so plus 3 root 5. And there we have it. And so when so in this case x equals 2 plus 3 root 5, and y equals 3 minus 2 root 5. So it was a bit of work, but good fun.